Hi, this is the Baseless Speculation Podcast. I'm Spartacus, and with me, I've got Dayman,
Hello.
iMacmatician,
Hello.
and Dylan.
Hey, fellas.
So, what we're here to talk about is a pretty cool thing that Intel just announced on Architecture Day. It's a brand new processor that's unlike what they've been releasing over really the past decade or more. What we're going to use to name this processor is the term Lakefield. This isn't our code name. This is a code name that was leaked by Ashraf Iyasa almost a year ago. And Ashraf mentioned a processor that was very, very, very similar to what we're seeing from Intel recently on Architecture Day. So we're pretty confident that Lakefield is the appropriate term to describe this processor. Intel didn't actually give it an official name. This unusual processor, Lakefield, came about because one of Intel's customers asked for a small form factor processor that had both relatively high performance, more than what was available typically, as well as very low standby power, much less than what was typically available. This is a pretty tough thing to do, and typically Intel would have Core M be the processor for this segment, but Core M just wasn't up to the task. And so Intel had to get a little bit fancy with how Lakefield is configured and put together. Now, we brought Dayman on to talk a little bit more about the Lakefield specifications and what makes it tick.
Lakefield features 4 little Tremont Atom cores and 1 big Sunny Cove core, which Intel detailed at their Architecture Day. Lakefield has a 2 mW standby power. Lakefield also has a 22nm I/O chip as the active interposer, connected to a 10nm compute die that contains the CPU cores and the rest of the processor. Lakefield is smaller than a dime, and it is destined for mobile devices such as laptops, 2-in-1s, tablets. Lakefield also features a quad-channel LPDDR4 memory controller, 64 EU design with Gen 11 graphics, Gen 11.5 display controller, a new image processor, and support for DisplayPort 1.4. The chip can enter C6 sleep states when not in use, has a die size smaller than 144mm square, and targets a sub 7W fanless device market.
Now, David, I want to stop you right there really quickly because you mentioned something that's really interesting to me. So you said that this thing has 4 little cores, and that are atom cores basically, and then 1 big core from the larger Skylake style line of the architectures. And the interesting thing here is that this looks a lot like something that ARMS did quite a few years ago. I remember one of the cool things is that Intel actually, back in the day, when ARM did this, and ARM called it Big Little. Intel, when asked why they don't really do this, I remember they always mentioned that they didn't need Big Little, right? Because Big Little is, because you use Big Little because 1 core can't do it all. Intel's kind of saying, well, we're so fabulous on our process technology and our architecture, and everything's so dynamic with the clocking and turboing that we really don't need to do something like Big Little. I always kind of find that funny that, back in the day, Intel didn't need this until a very interesting customer kind of, gives them a request that was really just too much for them, and they finally had to put together some interesting Big Little stuff. And we're going to be speculating on that customer here soon, but Dayman, I want to let you talk a little bit about what really it took to get to the standby power and all of the other interesting process and packaging things that went into Lakefield.
To do this, it took a number of new things for Intel, using different processes for different IPs. CPU cores use 10nm, the I/O uses 22nm. The I/O die uses a low leakage 22nm FFL process. Lakefield uses their new packaging technology Feveros to connect the 10nm compute die to 22nm FFL I/O die.
Now, one interesting thing that I always thought when I was reading about Architecture Day and this new Feveros technology is I remember hearing, I think it was at least a year ago, Intel talking about EMIB, right? Their embedded multi-die interconnect bridge that was for what seems a lot like what Feveros is, where they're kind of connecting these chips together, ultimately, and it kind of lets them mix and match different IPs at different processes that, suit those IPs. And actually, before this podcast, I ended up looking into this. What's going on with EMIB? Like, where do they stand? And it turns out EMIB is kind of the budget version of Feveros. So you really, unless you get a really difficult request, from a very exotic customer, then you really don't pull out all the stops, and EMIB is probably going to be good enough for you. So it's just putting chips next to each other rather than stacking them on top of fancy active interposers with some logic built in there. So it's a much simpler sort of setup. And from our understanding, looking at some different articles, EMIB's really going to be better for larger form factor installations where you're trying to stick two very high performance chips next to each other, maybe a very large CPU, that's targeting beyond 100 watts, and into the dozens of watts at least, and a large GPU that's roughly at the same sort of power level, and you don't really need massive bandwidth between the two. So you can kind of get by with what EMIB does. So I think that's an important thing to mention here with that ultimately, the shtick here is that this Feveros is ultimately 3D. So I think we've kind of covered what's going on with Lakefield, kind of a little quick background. The part where we're actually speculating, where we're providing some wonderful baseless speculation, is the piece about where this chip is going and who's going to be using it. Now, Dylan, you dug into some pretty cool stuff with Microsoft, and then I think iMathematician learned a little bit about Apple, and those are kind of the two front runners that we've got. Dylan, why don't you talk a little bit about that?
Going over the specs that you guys spoke about, it's clear that Lakefield is a very expensive Halo premium style processor. It sits above what Core M does at a higher level of performance, lower level of power, and just all around better, but also a lot more expensive. So, as you mentioned, there's two companies in the world that really are Halo and premium. Microsoft, who does the Surface line, which is the Halo for all Windows-based devices, and then Apple, who is just Apple. So with Microsoft, there have been a lot of rumors and patents about this product known as Microsoft Andromeda, the Surface phone, the foldable display. So what it is it's a dual display device that folds, has the full Windows operating system, and it can function as a phone. So basically it gives you the full productivity and power of a laptop PC, but the portability of a mobile device. And that's extremely important. There's been a lot of speculations based on these patents, and even a reference platform released by Intel that has two displays. But no one's not really sure exactly how it will look. What we do know is that it will probably be very high end, much like the Surface Book is. So the reason why I believe that it could be Microsoft Andromeda is because it uses, ultra low power techniques such as package on package DRAM like a phone, LPDDR4. It is incredibly dense, right? You're stacking these dies on top of each other just to save a little bit of area. You don't do that in a big device. You do that in a small device. At Intel Architecture Day, Lakefield was shown on a board that actually had modem, or not a modem, but a SIM card slots. So that tells you there's a modem on board. That tells you they're putting LTE on this device, whatever it is. And that tells you that it's going to be a mobile device that is connected to the internet via LTE. The other thing is that we know that it's a less than 7 watt fanless device. So phones typically peak at around 5 watts. So that would mean, this isn't the size of a phone probably. That's what most people have been thinking. But it also isn't the size of, a 15 watt laptop or a 10 watt laptop. So, it's somewhere in the middle between a phone and a, full on laptop, probably closer to where a tablet is. The other thing is that Lakefield has 64 execution units. That's a ton of GPU performance. For reference, the laptop, the modern laptop that you buy today with, an i5-8250U is, I believe, 24 execution units. So this is a huge jump, and these execution units are also a lot more powerful. And you need all this GPU horsepower to power the dual screens, which are probably very high resolution. So there's been some dual display demos also that were at Intel Architecture Day, which were powered by Lakefield, which is another indicator that it is a Microsoft device. So those are some of the main reasons we think that it'll be a Microsoft requested chip. I'm going to hand it off to iMac to talk a little bit about iMac-Matician to talk about the Apple side of things.
So Apple's portable computers are generally quite thin and light, and Apple also values low power consumption. For example, when the MacBook Pro was redesigned in 2016, a lot of people noticed that it continued to have a maximum of 16 gigabytes of LPDDR3 memory. Apple was not using DDR4. A Mac Rumors reader asked Phil Schiller of Apple why the MacBook Pro has this limit, and the response was, and I quote, "To put more than 16 gigabytes of fast RAM into a notebook design at this time would require a memory system that consumes much more power and wouldn't be efficient enough for a notebook." So eventually, Apple did move to DDR4, but that was only 2 years later. So even for the high-performance laptops in Apple's lineup, Apple still cares about power consumption. Also, in the last few years, many Macs have been able to offload some tasks due to the existence of ARM architecture coprocessors. These are known as the T-series chips. The first of those chips was the T1, which was used in the 2016 and 2017 MacBook Pro. It runs a watchOS variant called BridgeOS, and it's used for Touch ID and security features. It also has an ISP. Apple introduced the T2, which also runs BridgeOS and is similar to a single-core A10. So this is more powerful than the T1. It's used in the iMac Pro and the 2018 MacBook Pro, MacBook Air, and Mac Mini. Used for security features, video decode, storage controller. We can speculate maybe a T3 next year, which we can assume to have at least as many features as the T2. So Apple can reduce the usage of the 10 nanometer die of Lakefield compared to a product without such a coprocessor. Apple could completely power gate the 10 nanometer die for any tasks that don't need it. In those cases, the dies that are actually active are the T3, which would probably be low power, and also the low leakage 22 FFL die of Lakefield. So what happens is that Apple has a system that uses very low power during sleep, so a long standby time, and also low power during video playback and other tasks. But due to the 10 nanometer die, it can still have very high performance. And now, what Apple product would be the best to use Lakefield? Well, Lakefield is best for a relatively high-end product that needs a very low-power chip. And the 12-inch MacBook is probably the only suitable Apple product, since it's small, fanless, and also it actually isn't the cheapest Apple laptop. It has stayed at $1299 for the entry-level MacBook since its introduction. And unlike the base MacBook Air and base 13-inch MacBook Pro, which have 128 gigabytes of storage, the base MacBook actually has 256 gigabytes of storage. Apple is positioning the MacBook not at the low end, but slightly higher placement. The MacBook Air, that's Apple's budget laptop, relatively speaking. I know the new MacBook Air is a little bit more expensive than what a lot of people wanted, and the other Macs are all desktops or high-performance laptops that require more performance than what Lakefield has. The current 12-inch MacBook uses Kaby Lake Y, and it was last updated in June of 2017, except for some color options recently. Apple could use Lakefield in the 12-inch MacBook. Rumors from reliable sources, Bloomberg and Ming-Chi Kuo, that say that Apple will switch the Mac to ARM starting from 2020 to 2021, that time frame. Probably room for a Lakefield MacBook between now and presumably the ARM transition, and this would help Apple to move closer to this transition.
So there's some aspects of Lakefield that I think would actually lend itself to sort of being a bridge product in this whole ARM transition for Apple, which is surely going to happen, right? So as we spoke about, there's the 22 nanometer FFL die, and it has all of the I/O on it. And then there's the 10 nanometer die, which you spoke about being able to be power gated. If Apple used this product, they could use the 22 nanometer FFL die, access the entire memory pool, and perhaps go through the display engine which could potentially be in that 22 nanometer FFL die as well, and be able to do tasks such as video decode and maybe even offload core OS functions directly to that T2 or T3. So definitely wanted to emphasize that part, that it could help them actually offload a portion of the OS immediately and more tasks, and slowly start using the x86 aspect less and less and less. So it might not be, an immediate switch. It might be, 2019 they get Lakefield, 2020 they get, something that they can, transition even more stuff off, and then 2021 they're completely off of x86.
Dylan, do you think that Intel is going to be aware of what Apple's doing if they do kind of want some kind of hybrid solution? I mean, I can't imagine that Intel is very happy with all of the ARM transition rumors. So this creating Lakefield almost feels like they're enabling that. As you said, it wouldn't be the worst transition in the world.
The main reason I think Intel is going to comply with Apple's request, if this is Apple, I'm still leaning towards Microsoft, but if this is Apple, and they have to fight for this client, they can't just let Apple walk away. And if they didn't make this sort of product, right, they just said, you're going to deal with Core M, deal with it, sorry. Apple might leave a year or two early, and that's a ton of revenue that Intel loses. Whereas if Intel does this sort of, hybrid x86 with the I/O die and all that, they could hold on to Apple for a few more years maybe, and even keep them for a much longer than Apple was expecting. With this transition, everybody has to compare what is Apple's best SoC right now versus what Intel is going to provide them next year. And if you look at right now, Apple has the A12X. It's 4 Vortex cores, which is Apple's big core, very high IPC, and 4 Tempest cores, which is 4 little cores, versus a single Ice Lake and 4 Tremont cores. The A12X has a TDP of, probably greater than 5 watts, but probably less than 7 watts. Probably very similar to what Lakefield is offering. Maybe it's a little lower power. Probably is. As far as GPU from Apple, the only comparison point they gave us is that it's comparable to the Xbox One S. So now that's a little, I don't know if everybody believes that. I don't believe it completely myself, but we can compare that to what Intel is offering with the Gen 11 graphics, the 64 execution units. They're saying greater than 1 teraflop. I mean, that's pretty far short of the 1S, but in reality, I'm expecting them to perform fairly similarly. As far as memory interface, the A12X uses a lot more memory, so that might allow it to have better graphics performance. It has 128 bits of LPDDR4X, whereas Lakefield only has 64 bits of LPDDR4. So that's going to be quite a bit lower bandwidth. Then on top of that, we know A12X's, performance is quantified. Anantech has a lot of great comparisons with the A12X SoC to various other products, and it's a very impressive product on TSMC 7 nanometer. Whereas, and there's an option for an XMM 7560 modem, which is Intel's current modem. Lakefield could potentially be using what we think is probably either the XMM 7660, which is Intel's next generation LTE modem, or it might even use the XMM 8160, the 5G integrated modem. And as we saw in the Microsoft section, there's that board which includes SIM slots, so clearly there is a modem in the plan somewhere. So with that in mind, how would this Andromeda device compare? And wouldn't you think it encroaches on what the iPad Pro is trying to do, iMac?
Oh, absolutely. If Andromeda uses Lakefield, then it would have an Intel processor and essentially a full operating system. This is in sharp contrast to the iPad Pro, which Apple is trying to push as more of a laptop replacement in recent years. However, it still runs iOS. With the Andromeda having Lakefield, that would allow for a phone that you can put in your pocket. You can fold it out to something of tablet size. It's something that the iPad Pro just can't match at this time.
No, I think that there is some potential for Apple to do this, but I'm definitely in the Microsoft camp. The thing that really sold me was seeing two widescreen displays in an upright portrait orientation, and they're right next to each other, exactly like an old, Courier mock-up from 10 years ago, or a more modern Andromeda mock-up where it's a folding display. And the thing that gets me is I don't quite understand why Intel was pushing the dual display functionality quite so hard if this was just going to be any old Apple product that's inevitably going to go into a laptop or an iPad or whatnot, which are single display devices. It just seems so strange to be mentioning that and not having it go into something like Andromeda. So that's really my bet.
I'm in the Apple camp because, as Dylan said, Intel's got to fight for Apple. They don't have to fight for Microsoft. Apple has a lot more sway at Intel than Microsoft has ever had.
I mean, Apple pushes a lot of volume, and if there's any one company that could really properly convince Intel to do something like this, it might just be Apple. I mean, Apple does have a history of doing this kind of thing. I mean, the very first MacBook Air was had some custom packaging to be a little bit more compact than really anything else on the market. Nowadays, that's just the norm. But I mean, that was at least 10 years ago. when the very first MacBook Air arrived, the old one, the original one, and it had some special stuff from Intel, and we don't really talk about that, but Intel has a pretty decent history of providing Apple with some custom silicon, and it's going to be selling a lot. So, I can't imagine Intel would create something without a sizable order. Maybe Microsoft isn't quite bullish enough to be putting in the necessary order size to get Intel to create something this semi-custom.
Yeah, and just to give another example would be Iris Pro. I mean, Intel offers it to other companies, but let's be real. The only company that even uses Iris SKUs is pretty much Apple. So that's another, basically custom, right? And Intel said they're going to offer it to other customers, but they had one customer asking for it. So clearly, that's similar to what they've done with Apple in the past. Like with the MacBook Air, they're like, Apple probably requested it, Intel made it, and they're like, Ultrabook initiative. Or like Iris Pro. Apple requested it, Intel made it, and then Intel tried to push it onto a few other OEMs, but they were like, no way, this is way too costly.
Well, yeah, that's what Crystal Well was. Iris made for Apple and offered to other people, but no one else used it.
Also, one thing I will say is that the MacBook Pro technically has two displays.
Yeah, isn't that thing like something like stupid, like 2000 by like 1500 or 2000 by like 150, like some just ridiculously stupid resolution?
Maybe that second display is a big enough deal. To be this is almost turning into an Apple discussion to be properly on what that crazy fruit company is going to be doing. And good lord, we might have to have a sequel here on other Lakefield applications.
So maybe what if they go bezel-less on the MacBook?
We're kind of talking about
touch bar and then add a notch. Then you'll definitely need it.
Enigmatic consumer or customer that asked for this. Intel also mentioned that this is going to be discussed, or this is going to be used by all sorts of folks. Intel doesn't create these sorts of processors just for Apple or just for Microsoft or just for anybody. So I think ultimately we can expect to see this in a lot of different applications. So I'm excited. I'm pumped to, jump in a time machine and see what happens 12 months from now. We might have to do a sequel to see all the screwy things that some of these system integrators and other OEMs will do with this. But I think for now, we've got a good discussion here, and it's always great talking with you guys, and I hope our audience really, really enjoys this.